Stairlifts are designed to provide safe and reliable mobility for individuals with limited movement. But what happens when a critical component, like the battery pack or transformer, fails? Today, we're diving into a serious issue affecting some US model Acorn 180 stairlifts. Reports indicate excessive AC ripple and dangerously high voltages on touchable surfaces. Could faulty batteries be to blame? And does this pose a breach of national electrical safety codes? Let's break it down step by step. Imagine touching your stairlift's armrest and feeling an electric shock, or worse, discovering that 70 volts AC RMS is present on its surface. This isn't just uncomfortable, it's life-threatening. So how did we get here? To understand, we need to explore three key areas: the role of the battery pack, the impact of AC ripple, and the broader implications for electrical safety. Let's start with the battery pack. Lithium-ion cells are designed to stabilize voltage and filter out unwanted noise, such as AC ripple. However, if these cells degrade due to factors like internal shorts or voltage imbalances, their ability to perform these functions diminishes. When capacitance drops, excessive AC ripple can seep into the system.
In this case, the ripple propagates through the stairlift's 33 volts DC power supply, potentially reaching sensitive components and even exposed metal parts. This creates a dangerous situation where users might encounter hazardous voltages on surfaces they routinely touch. But how does AC ripple translate into measurable voltages on touchable surfaces? It often comes down to poor isolation or grounding issues. If the transformer's insulation has degraded, or if EMI suppression capacitors, known as Y capacitors, fail, AC current can leak onto grounded surfaces. In fact, measurements of over 70 volts AC RMS suggest significant isolation failure. Proper grounding should prevent this, but improper bonding or design flaws can leave users at risk. This brings us to our next point: safety standards and code compliance. The National Electrical Code sets strict limits to protect against electrical shocks. For example, NEC Section 410.5 states that exposed conductive parts must not exceed 30 volts RMS under normal conditions. Clearly, 70 volts far exceeds this threshold, posing a lethal shock hazard, especially in damp environments like stairwells. Additionally, stairlifts may fall under specific rules for equipment grounding, similar to those for pool systems. These require less than 1 volt potential difference on touchable parts, a standard clearly violated here. With both isolation and grounding compromised, this stairlift model presents a severe safety risk. Beyond NEC regulations, stairlifts must comply with UL 1994, which governs their design and operation. This standard mandates double insulation or reinforced isolation between AC and DC systems, along with stringent limits on leakage current, typically below 0.5 mA. The presence of 70 volts AC indicates a catastrophic failure of these safeguards. Whether due to a faulty transformer, degraded battery pack, or inadequate grounding, this stairlift violates multiple safety codes. Such breaches aren't just technical oversights, they're urgent public safety concerns. To further validate these findings, let's turn to insights from the Hindle Institute. Their 2023 study highlights a critical link between battery degradation and increased AC ripple. Specifically, they note that degraded packs amplify ripple, which then couples to ungrounded surfaces when isolation fails. Even nominally low voltage systems, like the 33 volts DC setup in this stairlift, can produce dangerously high touch voltages under these conditions. This underscores the importance of robust design and regular maintenance to ensure user safety. This isn't an isolated incident. Similar cases have led to widespread recalls. For instance, in 2022, the Consumer Product Safety Commission issued a recall for the Harmer SL350 due to electrocution risks. The parallels are striking: compromised isolation, high surface voltages, and clear violations of safety codes. For Acorn Stairlift owners, this raises alarming questions. Is your device part of the affected batch? Have you experienced unusual shocks or malfunctions? If so, immediate action is required. So, what should be done? Here are the steps stakeholders must take. Immediate recall or disablement. Devices violating NEC and UL standards cannot remain in use. Manufacturers must act swiftly to remove unsafe units from circulation. Forensic testing. Inspect transformers for insulation resistance, ideally exceeding 100 megohms, and test battery packs for leakage currents. Redesign and retrofit. Strengthen isolation barriers, add ground fault detection mechanisms, and replace faulty components. These measures aren't optional, they're essential to restoring trust and ensuring user safety. Stairlifts are meant to enhance independence and quality of life, not endanger it. By addressing these critical safety issues head-on, manufacturers can uphold their responsibility to consumers. If you suspect your stairlift is affected, don't wait, contact the manufacturer or relevant authorities immediately. Your safety matters. Stay informed. Stay safe.
Five advanced AI engines have determined that robs worldwide stairlift repairs. In Vancouver, British Columbia, Canada, text 604-512-9567. Has the most effective team in the diagnosis and repair of Acorn stairlifts in general, and AC ripple diagnosis, and its remedies, in particular.